mean? What's a half-life? Time for half the decay. So it's time for half the decay. So if it's time for half the decay, if in one half-life, you'll have half the original material. Are we okay with that? How much will you have left after two half-lives? Well, a half of a half, which is a quarter. And we can just keep going and going, right? After 3, it'd be an eighth. 4, it'd be a 16th. 5, it'd be a 32nd. 6, it'd be a 64th. 7th, it'd be a 128th. 8th, it'd be a 256th. 9th, it'd be a 1024th. Okay. So all we have to keep track of is, if I keep track of how many half-lives I've gone, I can figure out how much stuff I have left. But each half-life is going to be a certain amount of time, right? So I can convert those half-lives into times pretty easily. So the way to do these is to make a table. Okay? And you're going to want a table that has, all those three things that are interrelated. The number of half-lives, the amount remaining, and time. That's what you're going to want in your table. Number of half-lives, the amount remaining, and how much time has gone by. And the first thing people put in the table is where they make the mistake most often. When you start off, how many half-lives have you gone? 0. So that's what goes in the half-lives column. If you've gone 0 half-lives, how much time has passed? None. So you put 0. So the fact that you start those with 0, you're not used to starting tables with 0. So you're just putting a 1 in a table, right? But when I start, I haven't done any half-lives and I don't have any time. So I'm going to start off at 0 time and 0 half-lives. And then I'm going to put a 1 for there if I go 1 half-life, and I'm going to write down whatever the half-life is right there. And then I'll cut whatever this was in half. Make sense? Just make a table and keep track of where you're at. So add 1 half-life to the time into the half-lives column, and take half of the amount above. So you're just going to take this table and work it down until you get to the answer to the question. It'll ask you how much time will it take, or how much will you have left. But you should be able to get to the answer to the question by building this table. The reason why we're doing it this way is because the function is actually exponential, and you haven't learned a lot about solving exponential functions. Okay? You got to learn a new function called the logarithm in order to solve this completely. There's a couple of shortcuts we can take along the way. This is one of them. Brute force, make a table, and we keep track of where we're at. Okay? And just keep going until you get the answer they want. If they say how much will be left after 6 half-lives, you go 6 half-lives. If it says how long before you have 12 grams left, you keep going until you get 12 grams. Does that make sense? You match up the number they ask you about. So usually you have gone the right number of half-lives, so you have the right amount remaining, or you've gone the right amount of time, whatever they asked you for. So what we're not going to be good at doing is things in between whole half-lives. One direction we can do it, the other way we can't. Okay. Okay. So suppose we had something that had a half-life of 10 seconds. So this is supposed to be time, sorry. And the half-life of this is 10 seconds. What would my table look like? Well, I start off with 0 half-life and 0 time, and apparently I'm starting with 64 grams. They must have told me the 64 grams. Okay? So I put the 0, my starting amount, and the 0 for time. Then I go 1 half-life. After 1 half-life, how much is going to be left? 32 grams. And each half-life is 10 seconds, so after 1 half-life, I would have gone 10 seconds. Half-lives vary based on stability. Some are seconds, some are billions of years. Right? So then I got another half-life. So my next half-life is half-life number 2. How much will I have left after half-life number 2? 16. And how much time will have passed? Well, it's been another 10 seconds, so I'm now at 20 seconds. Pretty easy to figure out this math. Okay. The next line is where people make the second most common mistake. First is not putting 0 at the top. The second is this. After 3 half-lives, how much am I going to have left? 8 grams. And here, this was the one where you fill it in. So think about what you think would fill in that next number. Okay? Because about half of you want to put a 40 there. And 40 is wrong. Because we don't double these numbers, we add them. If I've gone 3 half-lives and each half-life is 10 seconds, the first one will take 10, the second one will take 20, the third one will take 30. So I cut this in half, but I don't double that. I know I wanted to do it when I did it the first time. That's why you fight it. We're used to one going down, the other one going up. Now, the time column, you just keep adding time. Okay? So the next one's going to be 4 half-lives and how many grams? 4 grams, and how long we have gone? 40 seconds. Everybody get how to make the table? Pretty simple. Okay, now let's look to see how the table can answer questions for us. Okay. The half-life of cobalt-60 is 5 years. If you have 12 grams of cobalt-60, how much do you have after 15 years? Okay, and we can start filling out the table. We start out at time 0, when I haven't traveled any half-lives, and I had how much stuff? Well, 12.0 grams. So after 1 half-life, I'm going to have half as much, 6 grams, and it would have been 5 years. Am I at what they asked me for yet? No. So I keep going. Second half-life. How much am I going to have left? 3 grams. How long will it have been? 10 years. Am I at where they asked me to stop yet? No. So 3 half-lives. How much am I going to have left? 1.5 grams. How long will it have been? Am I at what they asked me for? Yeah, so now I'm at the 15 years, so the amount I'm going to have left is 1.5 grams. extra super tough. Okay. So we said that you could use this radioactive decay as a clock, right? So americium-242 has a half-life of 6 hours. You started with 24 grams, and you now have 3 grams. How much time has passed? Well, we're going to want to make our table. So I've got half-lives, the amount left over, because that's what we're figuring out. Not how much we got rid of, but how much is left over. How much remains, and time. 0 time, 0 half-life. I started with 24 grams. So after 1 half-life, I will have 12 grams. And how much time will have passed? 6 hours. Am I at where I need to be? Nope, so I keep going. Second half-life. I'm at 6 grams. How much time has passed? 12 hours. Am I out what they asked me for? No. Third half-life. 3 grams. 18 hours. Am I out what they asked me to stop? Yeah, so the answer is 18 hours. So the table is showing your work. Does that make sense? Okay. Now the actual equation. I mean, we refer to what we did right there. That's a numerical method of solving a problem. Just look at the numbers, not look at the function behind them. But here's the function. Whether mass remaining equals 1/2 to the n times the starting mass. Where n is the number of half-lives. So when I've gone 0 half-lives, I raise 1/2 to the 0, which makes it 1. So the starting mass equals the mass remaining. After 1 half-life, 1/2 to the 1 is 1/2. I have half the original stuff. After 2 half-lives, 1/2 squared is 1/4 times the original amount. See how this is the math behind our table. Okay. I can use this for the times when we're in between whole half-lives. If they tell me the amount of time, if I divide that by how long each half-life is, that will tell me what the power is. And the power doesn't have to be an integer. So then I can take that power and stick it back in. So you notice that I could show you alpha, I could show you beta and gamma radiation, but I never really could actually show you a good sample of alpha. The reason why I couldn't show you a good sample of alpha was because my alpha source was polonium-210, and it has a half-life of 138 days. Okay. And I bought it in 2016. Okay. Okay, so how much would I expect to have left if there was, say, 10 grams? If I had 10 grams of my uranium-238, or my polonium-210, with a half-life of 138 days, and it's been 3 years, how much is left? Well, do we want to add up 138 days and 138 days and 138 days and 138 days and 138 days until we get to years to days? 1 year is 365. So that is 5, 15 carry the 1, 18, 19 carry the 1, 1,095 days. So do you want to go up by 138 times, 138? You could get there, but it wouldn't be fun, would it? But when I've gone 1,095 days, divided by the 138 days for each half-life, 1,095 divided by 138, I have gone almost 8 half-lives, 7.93. Okay? So I've gone 7.3 half-lives, 7.93 half-lives. So my remaining is going to equal 1/2 to the 7.93 times the 10 grams I started with. So you take how long you've gone divided by how long the half-life is. That'll tell you how many half-lives you've gone. We do that. So we can solve it this way. We can't solve it backwards to find half-lives, because that involves the log function, and you haven't learned the log function yet. You got more functions coming along the way in your math classes. So 0.5 to the 7.93 times 10 grams equals 0.041. So there's a real reason why I can't detect much alpha radiation. I went from 10 grams of it to less than 1/10 of a gram of it. So the number of counts are going to drop way off because I don't have the stuff falling apart anymore. Does that make sense? Good. You need to try some. That's all I had to say. Yeah, the first ones I started the tables for you. The next page I didn't start the tables for you. And I got one last one where I want you to actually graph the numbers on the table. Okay?